Hello, so I just wanted to start this episode by talking about the YouTube group that's been put together. There's a few people that have put it together who are part of the YouTube community, and I don't want to sort of name it individually through fear of missing somebody out, but if you go to the page, the admins on there are the people that put it together. It's a great place to be, so I do recommend that you all go and join up on that community. And the second thing I want to talk about, there was a member on there, and I cannot remember who it is, but somebody suggested putting like a network map together of all the YouTube communities, and then somebody else called David Jones has actually created that map, which is on the screen now, which I am a proud member of. If you go to David Jones' channel, for which I'll put a link on, he explains more about it. And I also believe that the map is going to be available for purchase in full size and also 00 gauge scale. So go and check that out. So go check out the YouTube community and go check out David Jones' video.
Hello and welcome back to Tony Lock Station. So, control panels. As you can see, I have had a bit of a tantrum and ripped it apart. These were fine, but I found that when I was putting the switches through, it was just a little bit too thick, and also on the bigger one, I was particularly there finding that the switches were too close together, and it had been slightly damaged. As you can see, some of the scratch marks there. So I was like, I'm just gonna rip it up and use the thicker Foamex, which I got with this as well, which was always going to be my plan B. And I have done those like that. So all the switches are in, the LEDs have just been put in. So as you can see, it's a thicker foam board. And I thought it would be maybe a little bit too flimsy, but it's actually quite rigid when it's sort of screwed in. So you see the LEDs are just placed in. These were pre-wired ones I've got, and all the switches are in as well now, just in position. And the bigger panel, it's a bit of a spaghetti junction here at the moment, but all the wires and switches are in. I just need to do the wiring, but I'm see, it's quite rigid. I'm quite happy just to even pick it up by the foam, and I'm actually happier with the switches. So as you can see, they sort of hold their own quite well, and I think that looks better, and I've spaced those out a little bit better as well. So as you can see there, they are quite close, which is what I was having problems with on the other one there, which was technically, it was 7mm thick, because you had the 6mm MDF and then the 1mm Foamex, but this is just 5mm, so it's a little bit easier to get the switches through with the washers and things on them. So overall, happier with that. So what I'm going to do now is go through the wiring. So if we look back at my original wiring diagram for the seat motors, we had the CDU, which is going to be my capacitor discharge unit, and that's going to be 16 AC, not 12 DC, so 16 AC coming in to the capacitor discharge unit and then out to the switch. So if I grab that, that's my discharge unit. So we've got the negative and positive going in, and the negative and positive going out to the centre panel, so centre terminal on the switch. So this will be mounted probably on the other side of this here, and then those two wires, which are just loose ones we replaced, will go to the yellow and blue bus wire over the back there, over there, to give me my feed in, and then that will then come out into here. So the negatives from all of the point motors will be fed along on a common return and into there, and then the positive will come out and then into chop blocks I've got two different sizes, thinner and smaller ones, bigger and smaller ones. The smaller ones are going to be for the LEDs and the bigger ones are going to be for the switches. So there'll be a rack of chop blocks there, and a positive will come in, and then I'll loop them all, so we've got like a common positive, and then I'll take positives out to each individual switch, rather than running lots of positives out of the discharge unit. It will be one wire in, and then like a distribution chop block to all the different switches. And then with these, the smaller ones, they will be feeding the LEDs, so there'll be 3 for each LED basically. You'll have the one side positive, the middle will be explained in a minute, and then the other side negative for the LED. So if you, because I'm using momentary switches, i.e. they return to centre, they're not permanently on, the LEDs can't be wired up to the switches because they'll just flash on and then off again. There won't be a constant power feed. So what I'm going to do is connect the LEDs. So for example, on this panel here, we've got this LED and this LED are linked to that switch. So if you flick it up, I know it's going to go straight ahead, and this LED I want lit. If I flick it down, it's going to bear right, and I want this LED to be lit. So I'm going to use the polarity from the frog to dictate which LED will light. So the LEDs will be wired up together with a positive and a negative leg connected together. So we'll have, say, a positive from one leg of the LED going in. The negative will then come out and be wired to the positive of this LED, and I'll have a negative. So I'll be left with a positive and a negative with 2 joined in the middle, and that middle will go down to the middle here, and then the feed from the frog will come here, and that will provide either positive or negative depending on which way the frog is thrown. So if this is negative, we'll have a positive feed coming in here, and then it will enable that LED to have a negative back through the frog. And then if the frog is flipped to positive the other way around, obviously that LED won't have a path, it will just be positive to positive, so it won't work. But this will then feed positive through into the second LED and allow negative to come out of here. So one LED will be lit or the other, depending on which way the polarity of the frog is. So whichever way I flick the switch will give me then hopefully a permanent on either or. And then obviously the route here would be, if I'm going to be taking this, I want both these LEDs to be lit. So for example, if I've got this LED lit and this LED lit, I know that this point still needs to be thrown, otherwise it won't go through. So that's why there's 4 on 2 switches there. Whereas this one here, obviously it's just one switch, it'll be the same, and that enables, if I flick it up, trains to go straight ahead, and down to go down into the dock area. So I hope that makes sense, but if it doesn't, then it will, once I start wiring it, actually show you how it's going to be connected. Okay, so it's looking a little bit confusing probably at the moment, but let me explain what I've got going on. So obviously these are my LEDs, I've counted out how many I need, and then these are going to be for my my motors to throw. I'm just trying to be very careful not to show something. I'm using the network cable to try and help keep the wiring neater, because this has obviously got looms of 8 cables, and then I can connect sort of multiples up rather than having to run lots of individual wires off, because some of them will be long enough to reach but sort of the ones at the top won't be. So I'm trying to run them down in like basically a multi-core, and so we'll have for each LED a positive, a joined positive and negative, and then a negative, which you can see, and then this green wire is a feed coming from a frog. So I've just got a positive and a negative just from the DCC wired up there, which then goes into the positive and negative, and then we will see that we've got an LED lit, and as you can see it's only one LED. So I'll try and get that from the front. Now I haven't wired it up to the exact point, I've just wired it up to a point just as proof of concept. So if I now change the point, you can see the LED changes. So I've just wired it up to this point here, just flicking it, and you can see the LED changing. So I thought I'd just test one, just as a proof of concept, to make sure it works, and it does. So how I've wired it up at this end may look a bit confusing because I've got two LEDs wired up there, but just one LED. So let's try and spread this out. So I've got two LEDs here, and I've joined knowing that my top rail is positive and my bottom rail is negative. So looking at the map, I know that this LED needs to have the positive one come into a positive feed, and this LED at the bottom needs to have the negative going to the negative feed. So it means I need to join the negative and the positive of this one, positive of this one together. So that's what I've done. Joined the negative and the positive of those together, and then fed that into a crimp. These I've found are gel crimps. They're a bit like blade splices, but obviously when I moved, I used to do a bit of fireworks, and we used to use these to join up firework igniters together, and they're like it's like a really super conductive gel inside there, which you might sort of be able to see just leaking out the bottom there. And so it's like a blade splice with a gel inside, so if it doesn't make an exact contact, the gel does help. So that's why I've sort of threaded the wires at the end so that they're in the gel, and then the blade splice goes through the insulation in the wire. So those two LEDs are joined together and going down into that white and brown. As you say, you just got to make sure you know what cables are which, because some of them are solid colours, and like this one here is a blue and a white, and this one's a white and a brown. So then the positive goes to the brown and the negative goes to the blue. It's just a different LED because I made a mistake on the first one. I ended up joining them together with an extra wire, then found out that wasn't necessary and that this is the best way to do it. And I tested that as well, and that works. So then they obviously go down into there. So this is the one I've just showed you, that'll be connected into there. And then from each frog you just take a feed in, and then obviously what I'll do is I'll have a common positive and negative sort of feeding all of these, rather than having obviously loads and loads of wires coming in. So I'll have like a common and positive and negative coming in here, and then I'll just sort of feed those out to each positive and each negative, just so I haven't got loads and loads of wire coming in. I'm obviously just trying to keep it as neat and tidy as I can and have the fewest amount of wires coming in to the panel, so that if I need to remove it for maintenance or replacing parts, it's a lot easier to disconnect. I've only got to disconnect like just the main in and outs, and then the whole thing can come off and I can basically service it on a space like this. And then obviously each individual bits and bobs can be replaced rather than having to chase wires all over the place. So these wires aren't obviously permanent, I've just done it to sort of do the test rig, but as you can see that system works. So now that it works, that's how I'm going to go ahead and sort of wire up the rest, and then I'll crack on with how I'm going to do these as well. Okay, so before it all starts to get a little bit confusing to the eye, as you can see I've got a positive here, which will be a DCC positive, which then goes into this chop block, and then literally just daisy chains all the way around to every positive terminal for the LEDs only. So that is the constant positive, and then what I'm doing at the moment is just daisy chaining the negative round, and then once that's gone round I'll have a positive and a negative coming out here, and then all I have to do is put each individual frog wire into its respective one. So as you can see I've done those, which I explained earlier, wired into there. And this is what I meant, that not all of them will need that. Some of the LED wires are close enough to reach, so they've just been wired straight in, which does make it a little bit more messy to the eye, but I think it will make sense with the labels on it and the closer one, so it's quite easy just to chase those wires. But then obviously like these ones, and especially those ones that are a bit further away, just use the network cable just to thread that through, just to make that a little bit neater at that end. And these little splice gel blocks are working great as well. And then once I've got all the LEDs wired up, I'll start wiring up the actual switches, because I thought this is going to be the most complicated and numerous of wiring, because for each switch there's 2 LEDs, and for each LED there's 4 wires. For each LED there's 2 wires, that's 4 wires per switch, and then having to duplicate them and then do all this positive and negative wiring as well, as opposed to just the constant positive and then the throw either way. So it is getting there. It's work in progress still, so I'm gonna sort of crack on with that, and when I get to the next major milestone I'll bring you in again. Okay, so what I want to do is just explain a little bit more on paper the electronic side of this. I made a mistake, so I've just crossed this bit out here. So LEDs are short for light emitting diode, and the peculiar thing about these is that they will only work if electricity flows through them in the correct path. So electricity must go in the positive and out the negative. If you send positive down the negative and then try and send it out the positive, the LED won't work. Whereas like with a normal light bulb, you can send positive or negative into either end and it will still work. So what I've done with these LEDs is put them back to back. So with LEDs, this is the symbol for an LED. It's a triangle with a flat bit and a line basically. And the way to remember it is electricity flows in the direction of the arrow. So electricity will only go in that way. Like on an LED, electricity can only go in one way. So that side is the positive and this line is the negative. So what I've done with these LEDs is joined the negative and the positive of one of these legs together. So if I just try and open this up a bit, bear with me a minute. So obviously black being negative and red being positive. These are joined like that, so you're left with one negative and one positive, with those being joined, and that join there with the positive and negative together goes up to the point frog. So ignore this crossing out. The negative leg is joined to the positive leg of this LED, and in turn they are then joined to the frog, and then the positive from your DCC feed goes into that leg, and then the negative out of that LED goes into that leg. So because the LEDs will only light one way, if you, for example, wanted to light this LED and have this one unlit, the positive will come through the LED, and then the point frog, because it can switch between positive and negative, when that is switched to negative, it allows the positive to come in through the LED and out to the negative of the point frog, and then that obviously goes back through your DCC negative. And then this one will not light because you've got a negative coming in here and then a negative from the frog. It's got 2 negatives, so it won't light. And then if you want this LED to light and this one to not be lit, you have the negative already there permanent, but then the frog, when it's switched to positive, will allow current to come in and through the LED and out to negative DCC feed. And this LED will not light because you've got positive coming through the frog and positive on its other leg, so 2 positives. So again, the current won't flow. So that, I hope that makes sense as to how the LEDs light individually and not both on together. You join the negative and the positive together, and then the frog will send either positive or negative to that join, which in turn will light the respective LED. So that's how it works on paper. And then if I just grab my trusty pointer pen, it is what I'm doing here. Just swap hands, sorry. So for example, the wiring up here, like I mentioned before, we've got a positive and a negative joined, and then that sends it to the frog, that little white wire there. And then we've got the negative and a positive from the other legs, and that comes down into here. So we've got a negative, the two join, the positive and the negative, and then a common positive. So that's a constant positive, a constant negative, and a variable from the frog. So that then enables the LEDs, which are those ones there are, these ones here, to be wired, to light individually depending on which way the frog is thrown. Now when it comes to wiring up which way they are, for me, the closest track to me is negative, and that one there, furthest away, is positive. So for example, that LED there, that point is this point here. So this is my negative rail and this is my positive rail. So I know that when I want it to go straight ahead, so I want the straight ahead LED lit, I know that the frog is in positive mode because I want the train to be going straight ahead. So I know that when the frog is thrown positive, I want this LED, sorry, I'm doing this backhanded, this bottom LED to be lit because that's the straight ahead LED. So it is the negative of that leg that I want connected to the constant negative, and then the positive to be the variable, because then when it switches I want two positives on there so it does not light. Sorry, two negatives so it does not light. So this LED, which is the bottom one, is fed to the constant negative. So as you can see, this top LED, sorry, it's the bottom one, it's the black wire there, comes down and it is on a constant negative. So this top one, it needs to be a constant positive, and that comes down and connects up to constant positive, and the other two are joined. So that when I want to send this LED to light, to send the trains up that track, which obviously doesn't exist at the moment, but in the future I want this LED to light, i.e. the trains to go this way, I've got a constant positive on this rail, so I need the frog to be negative. So I know that the bottom, the LED there will need to be the constant negative one. I've got ink all over me lovely new board, wash that off later. So that's how you then make sure you wire them up correctly, and knowing which leg goes to the common positive, constant positive and the constant negative, and then which two are joined. So I know that doesn't make a lot of I know it makes sense, but it's not very comprehensively clear, but I'm trying my best. So then obviously, as I mentioned before, this is just a loop of the common positives, and I'm in the process now of doing the common negatives, and then I will then send Cat5 cable from all the frogs and then in to all of the individual frogs for forever which point it is. So you obviously need to know that this bank of 3 is for that point over there, so I need to make sure the frog from that does come in here, because otherwise the LEDs won't light, so it won't change if it's any frog that goes in there. Obviously I want the polarity from that particular frog to be changing this particular bank of LEDs. Okay, so here we have the finished LED wiring. So as you can see, the switches still aren't wired up, but now all the LEDs are wired up. And yes, I'm fully aware that this looks like spaghetti junction. I am not the best when it comes to keeping wires tidy, but I've done my best and I've kept them all out of the way as best I can. And I've got enough room to still solder all my switches and then get them wired into these chop blocks here. And most of it will sort of move out of the way. I've left some flex in it to get in and out, but all that will happen now is, as you can see, I've numbered the banks for the LEDs, and they're just 2 LEDs per number, so 1 is LEDs 1 and 2 for number 1, and then numbered and through like that. So yeah, I've got 20 points just in this section here, which is obviously the this area of the baseboard that I'm currently on at the moment. So yes, I've just got now a positive and negative DC feed that goes in, and then they're all looped round, and then I'll have the Cat5 cable coming in with all the frog feeds, and then they will just go into each individual one as these are numbered. So point number 1, the frog for that, I know goes over there, and vice versa, so I know that the right frogs go to the right ones. And that's pretty much it. So what I'm going to do next is solder the common live between all the switches. So you get the middle pin, so let's just say for example I'll probably start with this one. Go to the middle pin, solder a wire onto there, and then it comes out here, so you've got your main power in and it goes straight to that switch. Then you take another wire from that centre pin up to the next one, and the next one, and the next one, and you daisy chain across all of the centre pins, so you've got a common constant live for your switches. And then the left and right pins of those switches will go to these, and then these will go out to the point motors themselves underneath the baseboards. And I'll probably run that on the Cat5 as well. So basically I'll have Cat5 for the LEDs, Cat5 for the switches, so it will help reduce the amount of wires I've got coming into the board. And then the last thing I'll have to do is take, I'm going to just create another negative bus, just as I've got some bus wire left out from under there actually. I'm going to create another negative bus that runs underneath the whole baseboard for the switches. The negative from the point motors themselves, you can see there'll be a positive and another positive to throw the switch, and another negative. That needs to go back to the negative of the CDU, so that's what I was thinking about, creating a negative bus that just runs just purely for the CDU, so then that will come back into the negative of the CDU. So yeah, I've done a lot of work, and I've only just finished the LEDs and I've still got all the switching to do. So I'm probably going to end this video here because I think it's going to be quite long as it is already. But yeah, LEDs all wired up, and then I'll do all the same for that panel, but that one shouldn't take too long, it's only a couple in there, but this was the main beast to get done. So all the LEDs all wired in and looking like spaghetti junction. And yes, then when this is all finished, this will get screwed onto the buttery biscuit baseboards here, probably about here, and then that one again on the other side. So yeah, all looking good, and I will see you next time. Thanks for watching.
Biscuit base. I like the buttery biscuit base. I like the base. I like the buttery base. I like the buttery biscuit base. I like the buttery base. I like the buttery base. Base knowledge. Crunchy base.